Programming language concepts including programming, scripting, and markup languages, and compiler vs interpreter. Compare compiler and interpreter together. Okay, difference between programming, scripting, and markup languages. Okay, what is programming language? Programming language are programming languages are a set of instructions or code which tells a computer what it needs to do. So basically we provide a logic or instruction to a computer to perform some task to get the desired output from it. For example, when we write a CD or DVD burner, we need to write some codes and instructions to do it for us, and that programming language is telling orders to hardware that to do that. For example, copying to flash drive or burning a CD. Programming languages now they are high level language, and means that it is they are nearly close to our language, English language, and that languages need to have some codes that transform our language to machine language. Computer cannot understand our high level language. It understands just zeros and ones. So we need a tool. We write the instructions in a human readable form, and then we hit the compile button to convert it into machine level language which a computer can understand, and then computer perform the task. This conversion is done by the compiler. Compiler is a piece of code that work for us. Scans the whole code in one go, and if it finds any error, it prompts us. Examples are Java, C, C++, C#. But what is scripting language? As the name suggests, it is all about giving the script to perform some certain task. Scripting languages are basically subcategory of programming language which is used to give guidance to another program, or we can say to control another program. So it also involves instructions. It basically connects one language to another language and doesn't work stand alone. This is a key word, stand alone. It doesn't work stand alone. Examples are JavaScript, PHP, Perl, Python, VBScript. These all are examples of scripting language. Scripting language need to be interpreted, scanning the code line by line, not like compiler in one go. Instead of compiler, there is no scope of compiler in scripting language. Scripting languages are most widely used to create a website. Because they are so interactive. And what is markup language? Markup languages are completely different from programming languages and scripting languages. Markup languages prepare a structure for the data or prepare the look or design of a page. They are visual, that we can see and interact with this page. For example, presentational languages, and it doesn't include any kind of logic or arithmetic or comparing, adding or multiplying or so on. For the HTML is not asking any kind of question to the computer, or it is not comparing things, and it's not asking any logical question. It doesn't ask for that. It is just used to present a view inside a web browser. It tells the browser how to structure data for a specific page, layout, heading, title, table, and all, or styling a page in a particular way. So basically it involves formatting data, or it controls the presentation of data. Examples of markup languages are HTML, CSS, or XML. These languages are most widely used in designing websites. From the above definitions, we can summarize programming language, scripting language, and markup language from below image. As we see this image, scripting language is a part of bigger family of programming language. Programming language include, for example, C, C++, C#, Java. Scripting language is JavaScript. If we learn JavaScript and Java, we have two tools that can develop. Yes, two tools that complete each other. Script language, other example, PHP, Perl, VBScript, Python. And markup language are HTML, CSS, XML. Conclusion. So we can say that all the scripting languages are programming languages, but all the programming language are not scripting language. Yes, look at this shape. Every scripting language is a programming language, but all programming language are not scripting language. It excludes. C cannot be called a scripting language. It is just a programming language, but we can call JavaScript or PHP programming or scripting language. Also, there is no need to compile a scripting language. It only needs to be interpreted. Scripting languages are generally slower than programming language because compiled programs are first converted into machine code. Whole of programs are once convert to machine code, and for next runs it executes that machine code stored in RAM immediately. On the other hand, markup language are just used to define the structure of data, which doesn't require any logic or algorithm. Yes, that is three concepts of programming language. These scripting language and markup language. Now we are going to know what is a compiler, what is an interpreter, and compare them. What is a compiler? A compiler is a computer program that transforms code written in a high-level language into machine code. It is a program which translates a human-readable code, just like English, to a language computer. That language that computer process and understand. What's that? Binary zeros and ones. The computer processes the machine code to perform the corresponding task. A compiler should comply with the syntax rule of that programming language in which it is written. However, the compiler is only a programmer and cannot fix. Compiler by own cannot fix errors found in that program. So if you make a mistake, you need to edit the source code and correct that mistakes of your programming, otherwise it will not work. Okay, what is interpreter? An interpreter is a computer program also which converts each high-level program statements into a machine code. This includes source code, precompiled code, and scripts. Both compiler and interpreters do the same job, which is converting higher level programming language to machine code. However, a compiler will convert the whole code in what step into machine code, create and exit before program runs. Interpreters convert code into machine code when program is running. How compiler was source code? In next level, compiler gets the source code and turns into a machine code, translates into a machine code. Machine code, CPU can execute that machine code and give our output. But how interpreter works? Source code by an interpreter interpret that source code and give our output. Both of them is giving us output, but compiler based language use a compiler. Interpreter based language use interpreter. When a whole code translates to machine code, it is faster on next running because all of which is translated to machine code. But in this interpreter, it interprets statement by statement or line by line. Overall time consumed by this is greater than this. Then after interpreting all code lines, it seems a bit slower than compiler based languages. Okay, I think you got the difference. Here is key difference too. Compiler transforms code written in a high-level programming language into a machine code at once before program runs, whereas an interpreter converts each high-level programming statement one by one into the machine code during program run. But compiler-based programming language, before run it converts the code to an exe file. Compiled code runs faster while interpreted code runs slower. Compiler displays all errors after compilation. On the other hand, the interpreter displays error of each line one by one. Compiler is based on translation, a linking loading model. It has a linker, whereas interpreter is based on interpretation method. Compiler takes an entire program, whereas the interpreter takes a single line of code. This key difference to consider it. And in this table we compare them. Difference between compiler and interpreter. Basis of difference: compiler and interpreter. Compiler create the program, compile with parse or analysis all of the language statements for its correctness. If incorrect, shows an error. If no error, the compiler will convert source code to machine code. It links different code files into a runnable program. Now as example, note that the whole program is not just only what we write. It has another peripheral files, libraries, or header files that in a different various files. Compiler links all of the parts together and make a single piece of code, and then run the program. But what interpreter can do? Create a program, no linking of files or machine code generation. Source statements executed line by line during execution. It executes, and during execution, source statements executed line by line. But it has advantage and disadvantage. Advantage are the program code is already translated into machine code, thus code execution time is less. Then for next times your machine code is ready to use, whole of your machine code. Interpreters are easier to use, especially for beginners, and disadvantage: you cannot change the program without going back to the source code. But interpret programs can run on computers that have the corresponding interpreter. This is disadvantage. Interpret programs can run on computers that have the corresponding interpreter. Machine code. Stores machine language as machine code on the disk, not saving machine code at all. It is on RAM or random access memory. Running time: compiled code run faster, interpret code but run slower. Model: it is based on language translation linking loading model. It's based on interpretation model. Program generation: generates output program in a form of exe, which can be run independently from the original program. Yes, when it turns to executable file. Now it is independent, but interpreter-based language do not generate output program, so they evaluate the source program at every time during execution. But what's the difference in execution? Program execution is separate from the compilation. It performed only after the entire output program is compiled. Yes, one whole or code translate to machine code, it executes. But program interpreter languages, program execution is a part of interpretation process. They mean that they cooperate with each other, so it is performed line by line. Memory requirement: target program in compiler-based language. Target program execute independently and do not require the compiler in the memory. One, it generates a .exe file. You can run it computer. But interpreter based, the interpreter exists in the memory during interpretation. It should exist in the memory. Best suit for what? Bonded to the specific target machine and cannot be ported. C, C++ are a most popular programming language which uses compilation model. Also Java is. For and this section is for interpret language. For web environments where load times are important due to all the exhaustive analysis is done, compilers take relatively larger time to compile even a small code that may not be run multiple times. In such case, interpreters are better. For example, notice that an exchange website that has many parts and needs to alter each of parts, for example adding coins or altering each part of that code. Then interpret-based language like Python is better for this type of use. Code optimization. The compiler sees the entire code on front, hence they perform lots of optimization that makes code run faster. Interpreters see code line by line, and thus optimization are not as robust as compilers. Dynamic typing. Difficult to implement as compilers cannot predict what happens at turn time. Interpret language support dynamic typing. Usage. Because it interacts line by line with us. Usage of these two branch of programming is it is best suited for the production environment, but other one it is best suited for program and development environment. Error execution. Compiler displays all errors and warning at the compilation time. Therefore, you cannot run the program without fixing errors. And the interpreter reads a single statement and shows the error if any. You must correct the error to interpret next line. You should correct one line, then you jump into next line. Input. It takes an entire program or compiled based, but in interpreter based it takes a single line of code. Output. Compiler generates intermediate machine code. Interpreter never generates any intermediate machine code. Error displays all errors after compilation, all at the same time. You say errors in C programming language, all of it at the same time. But next displays all errors in each line of code one by one. Pertaining programming languages are C, C++, C#, Scala, Java, all use compiler. But PHP, Perl, Ruby uses an interpreter. Role of compiler. Compiler reads the source code, outputs executable code, translates software written in a higher language into instructions that computer can understand. It converts the text that the programmer writes into a format the CPU can understand. CPU understands just machine language. 0 and 1. The process of compilation is relatively complicated. It spends a lot of time analyzing and processing the program. But what it is analyzed and processed, it stores in RAM and can run fast. 4. The executable result is sum from the machine specific binary code. And role of interpreter. The interpreter converts the source code line by line during runtime. Interpret completely translates a program written in a high-level language into machine-level language. Interpreter allows evaluation and modification of the program while it is executing. Yes. Editing is ready during executing. 4. Relatively less time spent for analyzing and processing the program. Program execution is relatively slow compared to compiler. It is overall time of execution. Then this is for line by line, because a line of code is smaller than a whole program. Yes. High level languages. What is high level language? High level language like C, C++, Java, etc. are very near to English. It makes programming process easy because you can understand English language. However, it must be translated into machine language before execution. This translation process is either conducted by either a compiler or an interpreter, also known as source code. This is another keyword. Source code. Machine code. What is machine code? Machine languages are very close to the hardware. Every computer has its machine language. A machine language programs are made up of a series of binary patterns like these 110 110. Each represents the simple operation which should be performed by the computer. Machine language programs are executable so that they can be run directly. Object code. And what is that? On compilation of source code, the machine code generated for different processors like Intel, AMD and ARM is different. To make code portable, the source code is first converted to object code. It is an intermediary code similar to machine code that no processor will understand. At runtime, the object code is converted to the machine code of the underlying platform. If you have Intel processor, Intel-based processor, it converts to Intel-based processor that your Intel CPU can understand it. If you use AMD, it converts intermediate code, object code, to whatever AMD can understand. And if you use ARM, and if you use that code, if you execute that code in a mobile phone, it turns object code to that ARM CPU. And Java is both compiled and interpreted. To explore the relative advantages of compiler or interpreter, some programming language like Java are both compiled and interpreted. Java is powerful. The Java code itself is compiled into object code at runtime. the JVM interprets object code into machine code of the target computer. JVM stands for Java Virtual Machine. Yes, and Java bytecode. JVM gives that, receives that Java bytecode and interprets to Java machine. And if you install a JVM in your computer, you can easily run bytecodes, Java bytecode. That's power of Java. Yeah. Okay. That is the concepts. I hope this video is useful for you. Thanks for watching, and comment me and subscribe to my channel.